Hello everyone, today in this video we'll be discussing the module 5 of cloud computing, and we have the following topics. There are 5 topics in this module. It is related to cloud programming and different types of software environment. Okay, we'll be discussing the important questions from this module, and if you watch this video till the end, you can score more than 80% marks in the exam. Make sure you watch the video till the end, and don't forget to hit the like button and subscribe to my channel. It helps make more videos like this. And if you have any questions, you can ping me on Instagram here. Okay, so let's get started with the first topic, which is features of cloud and grid platforms. Okay, there are two types of platforms: the cloud platform and grid platform. Okay, in this section there is a discussion on the important features of the cloud and grid platform. So traditional features common to grid and clouds. Okay, so in this section we'll concentrate on the features like the workflow, data transport, security, availability, concerns that are common to the today's computing grids and clouds. Okay, so important cloud platform capabilities. First is physical or virtual computing platform. Okay, the cloud environment consists of some physical or virtual platforms. There are two types of platforms: physical, which is the one which you are able to access directly here, and virtual, which is the one which is coming from the remote system. Okay, so physical or virtual cloud platform, both are available. Okay, and massive data storage service and distributed file system. Since you are utilizing the cloud computing, there you can store a large data in a different place. Okay, and it will be distributed file system will also be there. In a well organized way you can store it. Okay, massive database storage service, and whatever you want to perform the data to retrieve or store, all the services are available, you can do that. Okay, massive data processing method and programming model. If you want to perform some operations on the data, that will also be handled very well. Workflow and data queue language query language support. If you want to fetch some data, how do you do that? If you want to update some data, how do you do that? All that languages are also present. Runtime support is there, programming interface is there, and support services are also there. Okay, first is workflow. It determines the sequence of actions to be executed. Okay, if you are going to run a service, at that time what are the sequence of actions you are going to run one by one, that you have to define. That whole thing is called as a workflow. Okay, and in Azure or any old Linux machine, to run the workflow proxy services on external Linux environments. Workflow links multiple cloud or non-cloud services, real applications on demand. And data transport means transferring the data from one point to another point. That also has some costs associated with that. Okay, now we'll be seeing the different types of features of the cloud. Infrastructure cloud features. Okay, if you are going to use the infrastructure for the cloud features, you will be having the accounting, which includes economics, clearly an active area for commercial clouds. Appliances will be there, like the virtual machines, image supporting, and multifaceted tasks like message passing, MPI interfaces. Authentication and authorization will be present. Cloud could need single sign-on on the multiple system. Data transport is easy between them, and operating system is Apple, Android, Linux, and Windows. Okay, and traditional features in cluster, grid, and parallel computing environments. The traditional features which are already present is the cluster management. Different clusters can be managed. Data is manageable. Grid programming environment is present. Open MP and threading, portals. Okay, so different types of applications are there in the text present here. Okay, so you can go through the different architectures used. And platform features supported by the cloud and sometimes grids. Blob feature is supported for storing the data, like Azure Blob and the Amazon S3. And DPFS for data processing, you can use the Google's MapReduce, HDFS, and Cosmos Dryad. These all things we'll be discussing in the upcoming topics, because these are separate topics. Okay, we'll be discussing in depth. Fault tolerance is there. If any error happens or ignorance happens, what is to be done. MapReduce features are there, and monitoring and notification is also present. The third one is security, privacy, and availability. The following are the techniques related to security, privacy, and availability. Okay, so using the virtual clustering to achieve dynamic resource provisioning, use stable and persistent data. Special APIs are used for that, and cloud resources are accessed with security protocols like HTTPS and single service layer. And fine-grained access control is present. Shared data sets are present. Features are included for availability enhancement, disaster recovery, and reputation system for protecting data centers. So these are the features implemented for having security and privacy. Okay, now the data features and databases. Okay, there are many efforts which are made to design a VM image library to manage images. Okay, so there is a library in which all the images are present. You can use whichever image you want whenever it is required. Blobs and drives is for the storage purpose. DPFS is for data processing. Okay, for the data processing we'll be using some systems here like the HDFS and GFS. And SQL and relational databases to fetch the data, to interact with the data. Okay, we'll be using the relational databases. Now SQL as a service can also also be used here, and there are multiple NoSQL DBs. It emphasizes distribution and scalability. All the NoSQL table are schema free. There is no schema present in that. Both Amazon and Azure offer robust queuing services. Okay, Amazon is providing the storage and processing services, as well as Azure is providing that from the Microsoft. Now, programming and runtime support. To support the runtime and programming, what we'll be doing, that is the desired facilities to be presented in the parallel and distributed computing. Okay, and worker roles are basic schedulable process that are automatically launched, and web role provides an interesting approach to portals. Okay, portals will be there. You'll be using the web roles to access it, and workers role will be doing the background operations. MapReduce is one of the best users of data parallel languages. Now the main thing is we need to perform parallel processing. Parallelly many things should happen, and it should happen in different systems which are distributed across the world. Parallelly it should happen, and in different places wherever it is present, you should be able to access and perform it. Okay, so there are few of the systems are there, like Google MapReduce, Apache Hadoop, and Microsoft Drat, and Twister, and Azure Twister. Okay, so based on the programming model, data handling, scheduling, failure handling, HLL support environment, immediate data transfer, all the comparisons are given. You can go through it. Okay, next is iterative mapping. It is an interesting programming model that offers portability between cloud, HDC, and the cluster environments. Okay, means you will be able to switch between these services. SAS services are used in a similar fashion in the commercial and most distributed systems. Okay, now parallel and distributed programming paradigms. A distributed computing system is a computational engine connected by a network to achieve common goal of running a job and an application. If you want to run one job and it requires many systems, that systems can be present anywhere in the world connected via internet, so that you can be able to easily access and perform the operation. Parallel computing means simultaneous execution of multiple tasks. To run parallel program in distributed machines, the following needs to be taken into consideration. First is partitioning. Splitting means partitioning. Okay, if this is there and I say partition, means it will be it means that I want it to be split like this. Okay, now there are different types of things which need to be split, like computational partitioning. This splits a given job or program into smaller tasks. Data partitioning, it splits the input data or intermediate data. Mapping assigns smaller parts of program to the underlying resources. Communication, because there is data dependency, communication is important. Scheduling means which task when it should run, that thing. Okay, and now we'll be seeing the MapReduce, Twister, and iterative MapReduce. So basically MapReduce, what it does, it will take the data in the input, it will process the data, and it will produce the output. Okay, so here they will be doing the reduction and mapping of the data from one key pair to another key pair. Okay, so it abstracts the data from running a parallel program on distributed computing on large data sets. The interface are in the form of two functions, map and reduce. Okay, so this is the diagram. Here the MapReduce is there, MapReduce function, and once the mapping is done, after that the flow of data will go to the reduce function, which will output the files here. Okay, and the user interfaces can access the map as well as the reduce function, and they can override that map and reduce function for their own specific use cases. Okay, so it is generic function which can be overridden. The input is the map to the map function is the key value pair, and the output is the intermediate key value pair provided to the input of the reduce function. Whatever is the output from here, that will be provided to the input of the reduce layer. Okay, that's the main thing you need to know. MapReduce handles the partitioning, mapping, synchronization, communication, and scheduling details. The following steps are followed. Data partitioning. MapReduce splits the input data files already stored in the GFS into M pieces that correspond to the number of map tasks. Okay, so the data is partitioned. Computational partition also happens, where you will be handling the different users to write the programs in the form of map and reduce. Okay, that is computational partitioning. And next is determining the master and the workers. Master copies the user program, and the rest become their workers. So whoever copies the user program from the user to the system, that is the master, and after that whatever the process is to be done, that is done by the worker. Reading the input data from master to the worker. Map function is to map the key value pairs to intermediate key value pairs, and combiner is the nothing but the reducer function. Partitioning already discussed is nothing but the splitting of data, and synchronization means to synchronize map workers with reduce workers. If they are not synchronized, they will be doing something, that is of no use. Communication, all to all communication happens. Sorting and grouping also happens. Reduce function is to take the key value input and output the results in predetermined files. Okay, now MapReduce uses GFS to MapReduce data, which is Google file system. Okay, there are two problems with the MapReduce. Firstly, it is slow. Secondly, it is only for the selected data. The data only which is updated, that is getting transferred. The data which was already there, that is not getting transferred. This is solved using Twister, which will send all the type of data. Okay, so this is the diagram for it. Next is Hadoop HDFS, which is also a good alternative for the MapReduce. Okay, HDFS has a name node as a master and other nodes as a data nodes. So master gives the command, the name node gives the command, and the data node do the operations on the particular data. One of the main characteristics of HDFS is fault tolerance. Okay, there is a high throughput access to the large data. It can read and write based on request. It creates separate master worker nodes for the operation of reading and writing. The below diagram shows the architecture of Hadoop in MapReduce. Okay, so this is the MapReduce part, which is a top layer. It has a job tracker, task tracker, and each of the task tracker is assigned a job by using the job tracker. So the tasks are performed independently, and each of these is called as a node. Okay, so this is node 1, node 2, and node 3, and so on. Okay, and this whole thing is called as a cluster. And to run a job in Hadoop, the three components required are user node, job tracker, and task tracker. User node is which is giving the command, and job tracker manages that command, and task tracker does that command. Okay, so this is how the workflow will be. From the user, the job will be submitted. Job tracker will be assigning the task to different task trackers, and they will be performing the task and giving back the result. Okay, now the next one is Dryad and Dryad Link. Okay, these two softwares are used for parallel and distributed computing. Okay, for what it is used? For parallel and distributed computing developed by Microsoft. Dryad is more flexible than MapReduce. Okay, it can be defined by directed acyclic graph. It controls data flow through edges. Okay, you know the graph, right? This is a graph, and it controls the data flow through edges. Whatever the edges are pointing to means the data has gone from here to here, like that. Okay, and data partitioning, scheduling, mapping, synchronization, communication, fault tolerance are major implementations here. Job manager constructs, collects, and facilitates communication in the graph. Okay, so job scheduler will do all the management process, and the data plane will have all the data which is getting processed. Okay, and Dryad Link Queue is from Microsoft, aims to build a large-scale distributed computing available to ordinary programmers. The execution is divided into 9 steps. First is a .NET user application runs and creates a Dryad Link Queue expression. Okay, object is created. After that, it calls the table to trigger the data parallel execution. After that, compilation happens. It invokes another job manager to create a job, and it executes the vertex specific program, and it successfully writes the data to the output tables, and it terminates the program. Okay, and the control returns to the user application. Okay, so this is the diagram for it. Okay, next is Swazzle and Pig Latin. Pig Latin and Swazzle, those both are the high level languages. Okay, Swazzle is built by Google on top of MapReduce framework. It firstly there are 3 steps which happens here. Firstly, data is partitioned, and then it is processed locally on site. The local data is filtered to get the results. Finally, the aggregator writes the final results. So if we see the diagram, it is more clear. Raw data is present, it does the filtration, emitted data is gone to the aggregator, which sorts the results and sends to the output. Okay, Pig Latin is the high level language developed by Yahoo on top of Apache Pig project. Okay, it supports join in SQL, which is not present in the Swazzle. Okay, so this is the difference. So there are few more differences between these three, Swazzle and Pig Latin and Dryad Link Queue. Application classification for parallel and distributed system. Okay, so different categories are there, like the class can be synchronous, it is loosely synchronous, asynchronous, or pleasingly parallel. Okay, so based on that, the description is given here, and the machine architecture are given here. Different types of machine for different purposes. Okay, so there are totally of 6 type of machines. Okay, and programming support of Google App Engine. Okay, now we have discussed previous to this we have discussed about the Microsoft. Now we will be discussing the programming support for Google App Engine. Google App Engine GAE can be programmed using Java or Python. Okay, how is Google App Engine programmed? Using Java or Python. Okay, from the Java or Python it is being programmed, and this is the whole diagram, end-to-end diagram from the programming till the final use cases. Okay, so Google App Engine runs all the Google apps. Like, what are the Google apps? Docs, Google Docs, Gmail, Map, Excel, YouTube, and so on. All these apps are run by Google App Engine. Okay, if someone asks you how these apps are run, you should say Google App Engine runs them all. Okay, and a third-party application can use Google account for authentication. Suppose you went to a website, there it will be written login. Now when you click login, it will be given a login with Google account, right? That authentication is made by here only, the third party app, which is handled by Google App Engine. Now GFS is Google file system to store the data. Okay, but built as a storage services, it can store a large amount of data, and it stores in 64 MB block sizes. It is reliable, access is present always, and distributed consensus is there. There is no data cache present in the GFS, and POSIX file system is used, and you can even have the customized API to simplify the problem and focus on Google applications. And this is the architecture of Google file system. Okay, and in the architecture there is a single master and others are chunk nodes. nodes. Okay, what does chunk node do? Whatever the data is to be processed, they'll process the data. And master periodically communicates with the chunk servers to collect management information as well as to give instructions what next the chunk needs to do. Okay, so this is the 7-step data mutation process. Okay, so step 1, from the master the command comes, it goes to the client, and secondary replica does the first stage of operation, then primary replica, then secondary replica, and finally it goes back to the uh, uh, finally it comes and stays to the primary replica. Okay, so this is the control and this is the data. Wherever the highlighted arrow is there, that is the data, and the light arrow is there, that is control. Okay, so data mutation in sequencing GFS happens like this. Next is big table, which is the Google's NoSQL system for, for storing the data and handling the data. Accessing the data, will be using the big table if you are present in the Google system. Okay, so big table was designed to provide a service for storing and retrieving the structured and semi-structured data. Big table applications include storage of web pages, per user data, and geographic locations. Even Google Earth uses the big table. Okay, whatever you can see in the Google Earth, that is being shown through the big table. Okay, the main aim is to provide live updates of the data asynchronously. Okay, so it uses 4 things: GFS, scheduler, log service, and MapReduce. Now, to locate a table, the following hierarchy is used. From the chubby file, it goes to the root tablet and fetches the other metadata tablets. From there, the main tablet is fetched among the end users. And chublog also provides a coarse-grained log service to store the files. Okay, and programming on Amazon AWS and Microsoft Azure. Okay, so in Amazon we have few apps like EC2 and S3. So EC2 is nothing but it is a VM, okay, virtual machine, which you will use and pay by how much time you have used on that basis. Okay, and it uses Amazon Machine Image AMI. Okay, so 3 types of AMI are there: private AMI, public AMI, and paid QA AMI. Okay, and this is the diagram. You will be having a virtualization layer connected with the compute, storage, and server, which will be handling all the public images, public, private, and paid images. Okay, Amazon simple storage service, that is S3. Users can store and retrieve any amount of data via SOAP, which is Simple Object Access Protocol on S3. Okay, so key features are redundant throughout the geographic dispersion. There are many redundant databases, so that whichever location you're close to it, you can fetch the data from there only. And it's designed to provide 99.99% durability, and durability is very nice. This is the execution environment for the S3, and authentication is made, and pre-object URLs are there. There is default dollar protocol of HTTP, and it is very less. It is just 0.15 per GB per month storage, and there is no data transfer charge if you are transferring the data between the Amazon services. Okay, so the third one is Amazon Elastic Block and SimpleDB. EBS is a backup for EC2 images. In EC2, the VM images will be lost. If you want to keep a backup for it, you have to keep in EBS. Okay, Elastic Block Store. And SimpleDB, it's nothing but it is a simplified data model based on relational database model, like how we will be using the servers, right, for the SSMS. Like that, SimpleDB will be providing us all that. The data is organized into domains. Each domain can be considered as a table. Okay, next is Microsoft Azure programming support. In Azure, we'll be using the Azure Storage and Azure VMs. Okay, so there is a virtualized hardware dynamic assignment, and the DNS, which is the domain name system automated service management, is present. Okay, it supports the HTTPS and TCP. Roles offer the following methods: on start, on stop, and run method. And this is the diagram for it. Okay, how the Azure cloud platform is. From the fabric, it goes to the storage. From the storage, it goes to the compute, where all the computation happens through the web and the worker roles, and finally it goes to the users. Okay, and input and output comes from here only. Next is SQL Azure. Okay, it offers the SQL server. It handles the storage services. Okay, so from the account, it goes to containers, to the page or block blobs. Okay, and block blobs can be either 200 maximum. It can be 200 GB in size. Okay, to 1 TB. Next is the Azure tables and queue storage rules, which are aimed at much smaller data volumes. If you are working with small data, you can use Azure tables. Next is the emerging cloud software environment. This is the last topic, because we have 5 emerging cloud software environments. First one is Eucalyptus. Eucalyptus provides AWS compliant EC2 based web service interface for interacting with cloud service. It is providing an API or an interface. Okay, it uses both EC2 and S3, and this is the diagram for it. Next is Nimbus. Nimbus is an open source tool that provides IaaS cloud computing, which is infrastructure infrastructure as a service cloud computing solution. Okay, it provides a in-between interface. So the emerging cloud platform, whatever is there, the tools, they are the interfaces. Okay, it uses Python, Django, and provides web interface. It supports resource management. Okay, and third one is Open Nebula. It allows the existing infrastructure to transform into IaaS cloud with cloud interfaces. Okay, it allows to transfer the infrastructure into cloud interfaces, and it has the capacity to manage and schedule the data, and it has the design of the flexible and modularity. Okay, so this is the diagram for it, where we have been where we have the features present inside it, the drivers are present, and the local infrastructure is there, and the external cloud it is connected to, and the scheduler decides what task is to be done when. Okay, so this is the whole diagram for the Open Nebula. And the fourth one is the sector and sphere. Okay, so these are two like a pairs. Okay, it supports very large distributed data storage, okay, and simplified distributed data processing. It supports large storage and large processing as well. Okay, the system consists of sector, distributed file system. So what does sector do? Distributed file system. Repeat with me: sector does distributed file system, and sphere does the data processing. Okay, the communication is performed using the UDP for message and UDT for data transfer. Sphere provides a framework where data is stored, where data stored by a sector is processed. Okay, so security server is here, and the master is here, and the client is present here, and data is present here, which is performed, whatever the operation is going to be performed is performed here. Okay, so this is a sector sphere system architecture. The fifth one is OpenStack, open source community for sharing information, research, tech news, with the goal of creating massively large cloud data center. All the information which is ever is happening in the world, that can be shared openly in the open source website, which is called as OpenStack. So it is focusing on the development of two aspects of cloud computing, which is the OpenStack compute and OpenStack storage solutions. So OpenStack compute, it is the fabric of cloud creating and managing large group of virtual private servers. Okay, to manage the virtual private servers, you'll be using OpenStack compute, and OpenStack storage solutions is for storing the redundant scalable object storage data in many clusters in the form of community servers. It can store terabytes or even petabytes of data. Okay, so this is the diagram for OpenStack. Last one is the Mandrasoft Anika Cloud. Okay, so Aneke is a cloud application platform developed by Microsoft to support rapid development and deployment of parallel distributed applications. The development of parallel distributed applications will be done. After that, the deployment has to be done. This whole thing is handled by whom? Aneka. Okay, so Aneka acts as a workload distribution and management platform. It supports multiple programming, multiple runtime environment, rapid development, multiple virtual and physical machines, and it's based on .NET framework. Okay, and this is the diagram for it. It offers three types of capabilities. Building capability. It includes an USDK which combines APIs and tools to enable users to build the apps effectively. It also utilizes the Amazon EC2 server, and it is managed by Zen server. Okay, and accelerate. Aneka supports rapid development and deployment. Okay, whether it is Linux or whether it is Windows or Linux, it provides rapid development. Okay, and to manage the tools and capabilities supported by Aneka using GUI and APIs, so to make it easy for the end users. Okay, and this is the diagram for the private cloud resources along with dynamically leased public cloud resources. Okay, so this is all the things involved in the Aneka. Okay, and the following services are available at PAL, which is platform abstraction layer. In the platform abstraction layer, where the platform is not visible in the Aneka, the services provided are the fabric services. It implements the fundamental operations, and foundation services constitute the core functionalities, and application services deal with directly with the execution of the applications. Okay, an example is there. Aneka can be used to create application called as Maya rendering case study. Okay, Aneka has been used to create several interesting applications in the domain such as life sciences application using Aneka, and to reduce time, GoFront is also used. Okay, so this is the Maya renderer, and we'll be having the train here, and the data is coming from here. The locomotive and design files using Autodesk Maya. So here, whatever the data is present here, that you can see the Aneka has rendered it, and it is able to process the data, and it is also using a single server here, and this is the 3D utilities present here. Okay, and this is the LAN network. So these are all the this is one of the applications of the Aneka, which is GoFront Group, unit of China Southern Railways, China's premier and largest network researcher, and a manufacturer of rail electric traction equipment. The soft part is handled by Aneka. Okay, and VMs and P2P peer-to-peer network is also present in the Aneka. Compared to traditional approaches, the software distribution virtual appliances have benefit of significantly reducing software dependence on hosting environment. Okay, that's all for the module 5 of cloud. And if you found this video helpful, please like and subscribe. It helps me make videos like this. And thank you so much for watching. I'll see you in the next one.